Hey everyone, FusedVR coming at ya.
Hassan here.
And yeah, we're doing archery again. This is something that a lot of people have seemed to like. It's one of our more popular videos on there. You can see the bow and arrow, and we're not going to do all the setup that it takes to actually like build a bow and arrow from scratch. We're luckily SteamVR has a bow and arrow built in to SteamVR, which is kind of neat.
Yeah.
And so we can use that, customize it however we want. So today we're going to use it to do a grappling hook, which I'm so excited for. And I think you asked in oh, your video's going live, but
Yeah,
you asked in the chat if other superheroes used it, right?
Yeah.
So let us know, because I don't think I've seen any superhero use it, but I could be very wrong. I don't follow superheroes a lot.
Yeah.
So let's show this off.
Our only leads so far are the Green Arrow, who probably you guys have never heard of. I've never heard of the Green Arrow either. But you see, it's a pretty cool mechanic. I mean, so, basically anywhere you shoot, you can go.
And so I posted. I mean, if you follow us on social media, you'll see I posted a GIF of this a few days ago, and I got some interesting responses from the community. And one of them, which, I mean, obviously, if you get motion sick, this is not the experience for you.
Bad idea.
But what I thought was really interesting is someone told me about this actually hurts also with divergence accommodation conflict, where if I look at that tree and all of a sudden I zoom to that tree, my eyes have diverged to it. So that's another issue in regards to divergence accommodation, which I thought was interesting. So not just motion sickness. But if you're doing this for a short period of time and you don't get motion sick, this is super fun. You can just zip around the trees. It's really great for that. So we're going to build it, and hopefully you guys don't get motion sick either. One thing I will point out is you can actually do multiple chains. So I'm going to shoot that one up, and then I'm just going to zip over there. And whenever that lands, I get to follow that one too. So you can have a lot of fun with this. If you want to go Attack on Titan style, you can do that too. Just kind of getting multiple arrows. Not like Windlands, like Attack on Titan.
Yeah, exactly. Alright, everybody, I'll be in the chat. Hopefully we can make it active today.
Yeah, and we're going to experiment a little bit today and try to keep this one shorter than the other ones, just so that when I cut this down, it's a bit more manageable in the recording. But I definitely want to see an active chat. That's one of the reasons we do this live. It's super awesome to see that. So this is the project, really simple. You can see I only have one script here and one material. So, but as always, we're going to go ahead and start this from scratch. So go ahead and start a new project. Give that a second. Not into VRND. Let's go and put this into archery hook live stream. Go ahead and create that. And so while I'm doing this setup here, I'm going to go ahead and cut this out during the actual recording. But we're going to be setting up SteamVR and just getting that for a scene that we can use. And that's pretty much all we'll need. So we'll go ahead and do that, and ta-da! We got all what we needed. So we got SteamVR here, we got the hand-painted forest. Let's go ahead and make sure we have our longbow working. And we'll do that by going into the samples, we have scenes, and the interaction system. So this is, I've done a video about this before, but I'll show it again here. This is just a sample scene built with all of the stuff from the Valve's lab, So these are a bunch of different interaction systems. You have the teleport here. I'm going to go ahead, grab the longbow. See, I have that right here. The neat part about it is, whoop, I teleported too far. You can go ahead, light that bow and arrow on fire, and just go ahead and hit targets. So this is all built in. Super pretty customizable to do. I think the neat part, and this is actually one of my favorites about this, is you can actually switch into a 2D mode. It doesn't actually work with the longbow, which I think is kind of annoying, but and actually I don't even know where the longbow is in 2D mode. But you can do it in 2D mode. Kind of, if you're feeling lazy, that's another way to do it. VRTK also has this. The input there is a little different. They try to simulate both hands as opposed to this, which tries to simulate one hand. Very interesting, but I think the point of this is neither of them really simulate VR. And so I recommend just testing in VR always. So now that we know that that's working, let's go ahead. What we'll need is that player and the longbow. So I'm going to go ahead and copy those. I'm actually, because we're implementing effectively our own teleport, I'm not going to be using their own teleport with the teleport areas. If you want, check out our other video where we actually go over how to use that. But let's go ahead, and actually before I copy them, what I'm going to do is make a copy of this demo scene, and drag it out to the top here, rename this Forest, just so I have a reference to it. Then I'm going to go ahead and recopy them, just because I lost that. And the reason I want to do that is just so we don't touch the hand-painted forest scene. Go ahead and open that. Double-click on the first-person controller here. Now this first-person controller is basically where we want to put our camera. I think this is one of the best places to keep it. And let's just go ahead and copy the transform of this guy. Copy. Paste component values. That just goes ahead and moves the player over to that area. And then once we have that, we can go ahead and delete that. Go ahead and delete the first-person controller because we don't need that anymore. I'm actually going to go ahead and do the same thing here with our longbow. Perfect. Now, for this, since we're just kind of using it for teleport, I'm going to actually delete a lot of the things that come in as far as like a target is concerned, as far as the torch is concerned. Just we don't need them. So let's go ahead and do that. Go ahead, delete the torch, delete the torch pedestal, delete the archer weeble, and delete the teleport area, delete the title canvas, and yeah, we'll just keep the bow pedestal there because that's what we're going to be using. And then let's go ahead and move this longbow pedestal, the longbow pedestal down at about here or so, close to the player. There we go. So here we have that longbow. What I'm going to do is go ahead and then with the player, what I want to do is actually just enable the play volume so that we can but anyway, alright, so we don't need that. We can still see where the player is based on that collider. I'm going to go ahead and drag that down to be about on the ground or so, just because with SteamVR you get the height already built in, so you just got to make sure your camera sits on the ground and that capsule is like a little bit above the ground so that that represents your player. So with that, let's make sure we can grab our bow and put this on, make sure I can see this. And yep, there we go. Bow here. You can see it's the nice part about this scene is that there are all these colliders built in, and we don't have to apply them to the terrain or anything like that, which is just really nice as far as quickly prototyping is concerned. So with that, we're on our way to getting it working. Really quick before I move on, just for cleanliness, I'm going to go ahead and create a empty game object in the scene and just drag all of our forest game objects into it. Do that. Let's just call this scene. And then everything here, let's just drag it under, just so that I keep it clean and we just have basically three things: the player, the longbow, and our trees. Great. So now it's just time to go ahead and actually implement our grappling hook. So it didn't take too long to set this up. And for that, what we'll need to first do is actually go into the interaction system. Let's go ahead and find an arrow script. There it is. So here's the arrow script. Nice part about all of this is it's open source, so you can go in and basically just implement whatever you need to. So in our case, what I'm going to do is create two static events. What this will allow us to do is basically know when our arrow is released and when it lands on anything in whatever it hits. So for this, what we'll do is create a public delegate. All we want to do is call this arrow action, and we'll pass not me. We'll just pass in a reference to our current arrow when we do this. And then we'll create 2 static events based on our arrow action. This is on arrow landed. And we'll create another one, which is on arrow released. So just so that the arrow is already keeping track of this, so we just need to let anything outside of the script know that this has actually happened. So let's go ahead and start with on arrow released. Luckily for us, there's a nice arrow released function. So let's go ahead and so you can see here there's the fire source. We don't really care about that. We're gonna do this. We can do it pretty much anywhere that's not related to this fire. So I'm actually gonna do it at the top here. And let's go ahead, if it's not null, so we don't get any null references, just do on arrow released and pass the arrow reference, which is this. That's all we need to do for that. And for on arrow landed, let's go ahead and on collision enter, which is when that's actually detected, let's go ahead and add it there. For this, what I'm going to do is actually put it whenever it hits it, like when it moves relatively quickly. So it's not when the arrow accidentally drops out of your hand, or if it goes in, if you're still holding it and then it hits the ground. This is actually to make sure we've released it and then we're launching all the way over there. So that's where I'm going to put it in here, where we're checking if the speed is relatively fast. So for this, same deal, just creating our events and listening to them, or sending them out. Now, since they're static, we can easily access them without getting messy as far as like getting references to every arrow is concerned. So that's that for modifying the SteamVR interaction system. Just needed those 2 events. Now let's go ahead and write our own custom code. So for this, I'm going to go ahead, create a C# script. Let's call this teleport player. The neat thing is with this, we don't actually have to get a reference to our player. The SteamVR interaction system actually makes it an instance because you can only have 1 player in your game at any time, which is just kind of neat as far as being able to access that. So for this, what we're going to do is on start, we're just going to create our 2 methods. And before I do that, that's namespace, so just make sure you import valve.vr.interaction system. So we got that, and we have our interaction system there. Now we can access the arrow. You can see now it shows up. So on arrow released, just hit plus equals. We can tab to complete our method. Let's do this again with arrow.on arrow landed. Just create a separate method for that. Cool. We'll get to update later. We'll need it for actually making sure our arrows land. So what we first need to do before we get to the teleporting is just draw a line that comes and follows along with our arrow. For this, what we're going to do is basically create a line render. There are a couple, the concept, the reason we're using a line render is it's the simplest way to draw a long line. If you wanted it to feel, I guess, a little more realistic, you might try to use a mesh with like an actual, that has actual depth on the chain. That you then start to have to play with a lot of code as far as making sure those chains don't overlap, which just kind of gets annoying. Line renderer kind of handles that for us, which is why we're going to use it. And it kind of gets the same effect. You can play with the materials to kind of make it have that depth feel. So to do this, what we're going to do is just create a line render quote-unquote prefab. We're actually going to have it exist in the scene, but you can have it as a prefab if you want. That's just, we're going to copy that just so that we don't have to assign all our material properties during actual play. And that's just convenient. So let's just go ahead and call this the quote-unquote line prefab. And on arrow released, I'm actually going to move this up so that we don't have to worry about it too much. I'm going to just make a copy of that line prefab. So for this, let's go ahead, line render line equals instantiate line prefab. We don't actually have to assign a position to that because that's what we're going to be doing as we actually implement this. And then let's just do a quick few things for setup. Position count equals 1. The thing I want to emphasize here is actually for the line renderer, we're using Unity 561. You can see that here in the corner. The reason I want to bring that up now is because actually before the stream we were trying to set up mixed reality, which is kind of weird in 5.6. So the thing to keep in mind here is if you're using a version before 5.6, like 5.5, I believe this is called num position count as opposed to position count. I don't know why they changed the names, they just did. So keep that in mind if you are on an older version. If you're on the latest version, it's called position count. And then we need to keep track of this. And I think the best way to keep track of our line render is actually using a dictionary. So the reason for that is for each arrow, it's going to have its own line render. And as you saw in the beginning, if we actually launch that arrow super high in the sky and then launch a different arrow, you can have multiple line renders happening at the same time. And to avoid that, or to avoid the issue of reusing line renders, you can go ahead and create a dictionary to keep track of all of them. So let's go ahead and do that. Public dictionary arrow and goes to line render. And we'll just call this arrow lines and just do everything else we need to do to set it up. Luckily, autocomplete works nicely, and that's great. So we have arrow lines, and let's just go ahead and add our arrow lines to our dictionary. So luckily, we have a reference to our arrow, so we can just keep track of that. And that reference is actually going to be pretty important. As we go ahead and update it, we'll have access to the transform, so we can just plot those transform points. Sorry, it's not arrow lines. We're not going to do infinite recursion. And that's all we need. So now with our update function, what we can do here is just iterate over every arrow. And for every arrow, just update the line renderer by adding another point to it. So to do that, we're just going to do a quick for each loop. Arrow A in arrow lines dot keys. We're just going to iterate all of the keys. And it's not a method. Right. Okay, so now we have access to the arrow. What we can do is just get a quick access to a line renderer. L equals A. Actually, better idea. I'm just going to reference it like this. So arrow lines at A dot position count plus plus. So we need to increase the number of positions that we're keeping track of in our line renderer. And then arrow lines at A dot set position at arrow lines position count minus 1. And we're just going to set it to A dot transform dot position. So now on every time we launch an arrow, we're going to draw those lines. And let's also just go ahead and whenever it lands, just delete that line renderer. And then once we have that, we're like pretty much half the way there to getting that teleport going. So for this, what we're going to say, the arrow's landed. Then let's just go ahead and arrow lines at me dot. Let's actually first, here, let's just make a copy of this. Arrow lines at me, and then we'll just say arrow lines dot remove our reference so we don't keep updating it in our for loop. And the last thing we need to do is just destroy destroy L. And let's actually destroy the arrow also, because we don't need multiple arrows piling up in our scene as well. So there we go. We've destroyed the line renderer, we've destroyed our arrow. Whenever it lands, it just gets it out of the scene. And with that, let's go ahead and test it. Gotta make sure, nope. I need to make sure I add this into the scene. Let's go ahead, make a game object, add the teleport player. Let's just name this appropriately. Player. And hit play. Hopefully, actually, hold on. I should have to assign a reference here. But that's odd. I'll refresh this guy. Did it save? Did not save. I hate Visual Studios for doing that to me. Alright, there we go. Close that. Should be building a reference now whenever it compiles. The unfortunate part about Visual Studios is it breaks sometimes. But yeah, you can see that here. What I'm going to go ahead and do real quick is just create another game object. Let's just call this line. And add our line renderer onto it. Most of the stuff can be the same since we're just testing. We'll customize it after we test this. The only thing I do want to make sure we get rid of is setting the size to 0. And with that, let's just give it a shot and make sure everything works. And let's just call this line because I like having good names in the scene. Let's drag this onto here. Now give it a test. Sometimes I rush into testing without actually setting up things in the inspector. Let this turn on this controller. Alright, so we can see the controllers here. We'll go ahead and grab this. So nothing happened, and we saw a line renderer when it released, and it landed. So I'm going to go ahead and do that. It's gigantic and in my face, but yeah, you can see that the line renderer is there. Disappears when it lands. So we're doing a good job there. Awesome. So halfway there. Now, while we're in this position, let's kind of make it so that I can actually see what's going on. And to do that, I actually went ahead and on my desktop, I have here this texture. And this is I actually found this online. If you just Google something like a chain, kind of looks like the Steam logo now that I look at it again. But yeah, all you need to do is find some texture like this, make your own, whatever you kind of feel in, and you can use this as your chain on the material. Let's go ahead and let me know in the chat actually if you want to see how I found it. I don't think it's that exciting, but if you want to know how to find stuff like that, happy to do it. I'm gonna go ahead, say the texture is transparent, and let's go through this. Create a material. Let's just call this nope. Let's call this chain mat. And I'm gonna actually make this an unlit material texture. Here we go. Drag this on. Actually, sorry, I need to make it an unlit transparent cutout material. And what cutout does is it basically anywhere that's transparent, it just makes it transparent. It's slightly more efficient than a transparent shader in the sense that it's just either 0 or fully transparent. Doesn't actually do like 0.5 transparency or something like that. So that's just an optimization that they use to make the material a little better. But great, we have material in there. It works. Let's go ahead and apply it. This is the reason we made this a quote-unquote prefab, is so that we actually do not need to assign this material in our script. We're just going to assign it in the inspector. Saves us a bunch of time in setup. Alright. The other thing I want to do is set our width to be like, I don't know, maybe 0.1? Yeah, I think 0.1 actually works well. Let's go ahead and do that. This is actually, I think, a recent addition to Unity that you can actually change the width like throughout the whole line. I think in the past you used to be able to set the start and end, but now you can change it anywhere. So you can kind of make it a nice parabola, or actually, let's try that. I didn't try this in our initial one, but kind of want to see now what this looks like. Kind of make the chain kind of go nice and big. Alright, let's give this a shot. Bow. Oop, I don't know what I hit just now. Let's go ahead and set that there. That's wonky. Where is it starting from? That did not. It's interesting. Oh, I'm destroying the arrow script, not the game object. We'll fix that. But I think, yeah, what this looks like is our chain is a little too small. But you can kind of, can I see the, no, it doesn't look like it's getting that much bigger, which is weird. Go ahead and make this like 0.5. Oh, right. That would be why. I made it, should be based on 1, it's 0.1 of 1. Alright, let's try this out now. Oh, right, I should be using transparent. It's actually kind of a weird effect. Looking at it, it's kind of a wonky, really wonky effect. So, a couple things. One thing I just noticed a bug. And that is actually, so we're setting the position count to 1 when we release it, but we're not assigning an actual position. What that actually ends up doing is we have one position set at 0, 0, 0, which is why you see that really long stretch on it. So I'm actually going to go and fix that by setting the position count to 0. And the other thing is, this material seems wrong. Well, it looks right here. Maybe it's just super stretched. Let's try this again. I mean, it looks right in the material editor. Let's give it a shot. One more time. This is why we test early and often. Yeah, there we go. You can see it actually getting a little bigger, which is why it warps. I actually really don't like the effect whatsoever, so I'm going to delete it. It's also stretching. Oh, that's why. Let's do a couple things. So one on the line renderer, it's actually stretching it as opposed to repeating it. You can see that on the texture mode. So let's go ahead and set repeat per segment. That'll just add multiple chains. And I'm also just going to delete that key, delete that key, set this to 1, just so that we can get a better sense of what the control is. Alright, so now, let's go ahead and try this out. There we go. Now we're getting somewhere. And okay, one of the reasons for this being super weird is I shot it over the terrain a little too strong. And that's, I never got the on-collision entrance, so that arrow is going forever. Which, it is what it is. Here, the other bug is we're not actually on the arrow prefab that gets instantiated with our bow and arrow. What's happening there is we're just deleting the arrow script and not the actual game object. So the mesh and all that stuff is still there. So we just have to make sure we delete the game object. Yeah, we're about probably 70% of the way there. We got pretty much all of the code we want around it working. the only really other thing we need to do is teleport us. And to do that, I'm actually going to go ahead and create a coroutine. So let's go ahead. Enumerator, arrow, teleport. So for this arrow teleport, what I'm going to do is create a, not a line, we're going to pass in the line renderer L. And luckily for us, the line renderer gives us access to all the positions. We can use that to enumerate over all the positions. If we want to speed that up, we can even actually skip through positions. So that's what we're basically going to be doing here. I'm going to move this destroy to the end. So we want to keep track of it until the very end. We can still destroy the arrow. And we do also want to remove the line render from here. So let's go ahead, put a start coroutine here. Let's pass in L. And alright, so for each L dot, not lock, L dot, why is it not auto completing? L odd, okay. For each vector 3, pause and L positions, get positions. Actually, let's go ahead and get it as an array outside of here, just so that we're not iterating over each and every one. So this is vector 3, an array, not vector 4, vector 3, pause, equals this. L dot. Oh, interesting. I have to pass it in. Alright, so let's do that. I thought you could get it out, but I guess not. Vector 3 pause, new vector 3 from L dot num. No, I guess you do have. Interesting. All right, so get the position count, and that's just how many spaces we want to make, and then we'll just say L dot get positions, and put that into our array. We don't need this anymore, and I'm gonna also create for. I'm actually, instead of doing the for each, I'm gonna do a for loop. The reason for that is so that we can control the speed a little bit. Equals 0, I less than pause dot length I plus equals 5, so that we can do it really fast. If you want to do every position, you can do it really slow. If you want to start interpolating and make it a really slow lerp, you can do it, I guess, every half, and then every half it's in between 2 points. You do a whole bunch of things to get that whatever speed you actually want working. We're just going to skip through a bunch of points to make it a really fast movement to it. So L.getPosition, and then what we're going to do is say player.instance.transform, not tracking, transform. It's one of those things where you try really hard to get the correct syntax, but then you mess up. Anyway, get position at I. And keep looping, make sure not to have the yield there. Let's have the yield in our for loop. Here. And then the last thing is destroy the line renderer when we're done. And we're starting the coroutine. Okay, oops, and let's make sure to actually do the correct syntax for our coroutine. Tell it to do arrow teleport. Let's also call, just for sanity's sake, call stop all coroutines before this to make sure that we are not running multiple coroutines at the same time, and then if you actually launch 2 arrows and they land kind of approximately at the same time, you don't like jump back and forth between them, because that would be really bad. So let's just stop one so that if you're mid teleport, you'll teleport to the other one instead. You'll teleport to whatever the second one is, to save the player from a big headache. And yeah, that pretty much does it. let's go ahead and test that out. Make sure we can teleport around. And alright, put the arrow, teleport there, boom, 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 boom. Wherever we want, we can teleport to. And yeah, wow, we rushed through it. I just wanted to make sure we got through it really fast because there's really not a lot to it. As you can see, we made that small change to the arrow just to get the events, and now we can do that. Oh, I'll also check to make sure we can launch multiple arrows at the same time, because I think that's an important part of this. Let's go ahead, grab the arrow, launch that, teleport there, and whenever, oh, okay. That was interesting. But yes, we can teleport, and I'm stuck in a tree now. Let's get out of this tree. Let's go all the way over there. Let's launch that a little slower. Oh, I can't see it. But yeah, there we go. It works. You can launch as many arrows as you want. The nice part, the trick to it really is this dictionary. It basically, it's a really convenient tool to basically allow us to map each arrow to the line renderer and have it be unique. And so it lets us easily access everything we want. So I just want to read through it. If you haven't noticed, we're both like dying sick also.
I still have the hole in my stomach.
You're gonna get a hole forever.
I'm empty on the inside, guys. Another pun.
Get out of here. Alright, see you guys later. We'll stick around in the chat for a bit too.